Good day, students. This is 6.5 on assessing normality. So what do we have to do? Since the condition for sampling distributions and so forth is to either have a normal curve or a large sample, sometimes when we have small samples, what we really want to do is we got to see if the original population is at least close to normal so our samples can be a little smaller. And there are really two ways for us to do this. There are dozens of ways, but there are two ways we typically do this at the beginning. Number one is we make a histogram of the data. And by the way, we can do this for sample or a population. And if we look at the histogram and it looks fairly normal, then we would say, oh, we have a normal distribution. But if it's wildly not normal, all right, if it's not normal, wildly, I mean, then we would assume our distribution is not normal and we would move on. So in general, we're looking to see if it has a bell shape, and if it has other shapes, right, that aren't a simple bell curve, then that means it's probably not normal, okay? Number two, the second thing we can do is a normal quantile plot. Now, the thing with a normal quantile plot is you really cannot do it by hand. You have to use technology to do this. And so I'll kind of talk you through that. And so you'll be able to do it on a test if you need to. All right, so here we go. So what I want to do is I want to take a couple of pieces of data. I'm actually looking at page 302 in your textbook, and I want to determine if the data gives me something that is reasonably normal, and so I want to decide that or not. And so here's how we're going to do, that's what we're going to do here for the next couple of things, just do a couple of problems. So the first problem I looked at on page 302 was the M&M data problem, okay? And so the M&M data problem, I got something going on here, sorry. The M&M data problem wanted us to find out about the red M&Ms, there's the data in the column over there, and find out if it was normal. So what I did is I could get the data downloaded in Excel really easily, and then in Excel I just used insert graph, and I grabbed the histogram, and it just made a histogram of that data. And typically when Excel does that, it makes 5 categories. And so 0.81 is the boundary, 0.844. So it goes through, you don't have to divide by 5 and do that, but it lists the boundaries down below and it makes it. And so is this, I'm not really asking if it's normal, I'm asking if it's wildly not normal. And in this case, it's skewed, but it's not wildly not normal. So I would say that this data set is probably normal, and then I could go from there and use that as a criteria. Okay, let's look at another data set. So here's the next data set. This one is for Disney wait times. You can see the data set here. It was waiting at the Small World ride at 5 p.m. And I just made a histogram, which popped up right here. And I can notice when I look at this histogram, if I kind of draw it, that this is wildly skewed to the right. In other words, if you notice, the other graph kind of, even though it was skewed, it still kind of had a bell shape to it. This one doesn't even have that. It's just really high on the left and then stretched out way to the right. And so that says to me that this data set is probably not normal. This one's at least approximately normal. This one is not normal. Okay? And that's kind of how you're doing it when you look at these data sets. Now, I found Excel really easy to kind of look at these. You can also download the data sets to your calculator, although that's a much harder process. So Excel's really fast. I think you could probably download them to StatCrunch too. But when you have a big data set like this, you don't necessarily want to waste time drawing the histogram. So you want technology to do it for you. And that's what's happened here. And so we're able to make a decision. Okay, let's go on. Okay, now let's do this with the normal quantile plot and see how we can get those as well. Okay? Okay, so here we go with a normal quantile plot. The first thing I have to do is I have to enter the data in a list. All right, and so if you remember, that is press stat, and then press edit, and then you can enter the data into a list. All right. And so I did that with the M&M data, which was about 40 or 50 weights of red M&Ms. All right. And so once I did that, I have all the data there, and then I go to step 2. Step 2, after I enter the data, then I want to go into my plot function up here, which is where my statistics graphs are. So I press second plot. And once I do that, I make sure the graph is turned on. I can pick any color I want. I then choose the quantile plot, which is the last one. Okay. And then I can pick how it marks it on the graph, tell it where the data is, list 1, and tell it the data axis, X. And just so you remember, the lists are above the numbers down here. Okay? So blue, press whichever number. That's how you set it up. Once you have it all set up, then we go to step 3. And step 3 is the most important step. You will not see the graph unless you do step 3 correctly. Okay? So, how do you do step 3? Well, if you looked at all the red M&M data, all that data was going from 0.81 up to like 0.991 or something like that. I don't remember exactly. So what I needed to do is I need my X minimum to be smaller than the smallest one, and my X maximum to be larger than that. And so I put 0.8 and 1. That was smaller than all the values, and 1 is bigger than all the values. And I need it to be fairly close. I don't want to put like negative 100 and 100, then the graph will get jam crammed in a little dot and I can't see it. So I want to be fairly close to the values, but pick the smaller one and the larger one. And then I scale it by anywheres from like 1/4 of the distance. So 1 minus 0.8 is equal to 0.2. and then I take 1/4 of that, 0.05. That just puts marks on the x-axis, so I can see where the numbers are. Then the y-mins and y-max. So what is a quantile plot? Well, what it does is it plots the data value with the z-score of the data value. So in other words, all the z-scores for all the data are found by the calculator. This is where all the time is saved. This is why you don't do this by hand. You let technology figure it out, whether it's Excel or your graphic calculator or StatCrunch. You let the technology figure it out. And so my z-scores are significant, right? Typically when we draw normal curves, we go from -3 to 3, right? That's 99.7% of the data. So that's usually a good choice for your y values, -3 to 3, okay? You can choose others, but then what happens is it squishes things together and makes it look flat. And you kind of want it to go across the screen so you can see if a line fits it or not. All right? And so now, once I do that, I just press graph. And boom, there's my graph. You can see my y values went from -3 to 3 right here. -3 to 3 up there. And then the x values went from 0.8 all the way out to 1. And the data, the biggest one was about 0.96. Now, what you have to do is you have to look at this data. And you ask yourself, if I were to draw a line where about half of these dots were above the line and half below, would it basically fit through that data really good? And the answer in this case is this almost looks like a line with the data. Since that is the case, you would then say, this M&M data, it's okay to assume it's approximately normal. Okay? Now, if the lines were exactly on a line, that means it would probably be normal. But since they're fairly close, they don't bounce too far away. And if you remember the histogram went kind of up and then it kind of tailed away like that. And this is kind of where it popped up, and here's where it's tailing away. And so I got a feeling that this data is approximately normal. Now, I'm not going to do another one of these. But what happens when the data is not normal? Well, what'll happen is when you do your normal quantile plot, you kind of get something like this. And when you draw it, it looks like a little sine curve over the line. If you get something like that, it's distinctly not normal. Okay? And that's why the normal quantile plot is even better than the histograms, but helpful nonetheless. Okay? And so if you get wide openings off of it where the line's not going through, or you get a sweeper up here or down here, that usually indicates it's not normal. And that's how the quantile plot helps. Now, the challenge if you're using a calculator is you have to enter the data. So when we take a test, if I ask you to decide if some data is normal, I would probably have like 10 pieces of data, not 40. Okay? I would shrink down the data set and I wouldn't have you doing as much. All right? So that's kind of the thing you want to pay attention to. You may do a problem or two with technology now where you got 40 or 60 or 70 pieces of data, and you just kind of work through the process once or twice to make sure you understand it. But that's how you do it. So do that. I will not ask you to do these by hand. They do show you how to do it in the textbook with small data sets, but I'm not going to ask that. I don't think that's important. Even with a small data set, I would just do it on a calculator. So there's your steps, there's your process. Good luck with that. Now, let's talk about section 6.6. I just want to mention this briefly. Section 6.6 is called the normal as an approximation to the binomial. We're not going to do these problems, but I need you to understand something. Because we have technology, all right, we can calculate binomial probabilities using the binomial PDF or binomial CDF functions. Okay, we can do those fairly easily. In the past, you wouldn't be able to do that so easily. And so you would use the normal distribution to approximate binomial distributions. Why could you do that? If you remember, binomial distributions were histograms. They were individual probabilities, and they would create histograms. And once the size of the sample got big enough, the histograms began to look like normal curves. They began to become bell-shaped. And therefore, we could use the normal curve to approximate, if I wanted to be greater than this on the binomial, we could approximate it with a normal curve. Now, that normal curve would sort of miss the area here, but pick up the area here. So it's a little calculus-y in terms of how it did it. But I just wanted to mention that we could approximate that. And the key thing that this has in this chapter is that if you have a binomial distribution, the mean will be n, the number of trials, times the probability of success. And then the standard deviation will be the square root of n, number of trials, times probability of success, times the probability of failure. Okay? And this then helps us. Now, because we have technology to calculate binomials, almost nobody does this anymore. When I used to teach stats the first times back in the 90s, I had to teach this all the time because these weren't on calculators. Even the early graphics calculators, they weren't on there. But now it's on there, and we don't even have to approximate binomial distributions anymore. But I did want to mention this again, that the mean of a binomial is NP, and the standard deviation of a binomial is square root of NPQ. That's something that it's worth reminding you of. Other than that, that's all we have for this section. Okay? And so you are actually good. And I think this actually means, let's see, we'll talk about this on Monday. So we want to do a review on Wednesday. And we want to take a test on chapters 4, 5, and 6 on Friday next week. Now, if you are a student who needs to use the Learning Center to take your test, you want to schedule that starting on Monday, and you can start to schedule it for probably Friday, anytime Friday, or you can take it on Monday or Tuesday the next week. So if you're an athlete and you're gone on Friday, I want you to schedule your test for Monday or Tuesday. All right? If you are, and I don't want you to get late. Starting to schedule them later it means you get behind. You haven't taken the test. I can't grade it until I get all the tests, etc., etc. So let's make sure that you try and schedule for Friday, Monday, or Tuesday to take that test. Okay, I'll talk to you later. That's all I have. Bye.